This video is about conservation of energy. Conservation of energy is one of our most important physics rules. Basically what it says is the total energy of a system of objects is constant. So when we say a system of objects, that's any group of objects where we're not having any energy flow in or out of that system. So no work, no outside force is being applied to that system. A good example of something that conserves energy, well, everything conserves energy, but a simple example would just be a swinging pendulum. As the pendulum gets pulled back, something does work on it. Let's say it pulls it back so that it has a total energy of 10 joules, and then it's released. So it's going to swing back and forth like this. Now, since energy is always conserved, the total energy at all of these points is going to be 10 joules. So that means that the total between KE and PE has to add up to 10 joules in all those situations as well. Here, it's as high as it gets off the ground. So if this is its highest point, it would be 100% PE at that point. Same over here on the other side. Now, my pendulum did change sizes because I'm not an art teacher. So KE then has to be 0 joules at both of these points. At its lowest point, the PE is going to be 0 because it cannot get any further down. The kinetic energy then would be 10 joules. Halfway down, the potential energy would be half because the height's a half. Also halfway up, same thing. The kinetic energy then has to add up, so it would be 5 joules there as well. If we wanted to find the speed of the pendulum at its lowest point, well, we'd have to find something that, if we're looking for V, we have to find a formula that actually includes V. So that would be KE is 1/2 mv squared. If we just say that, so I didn't include this in the problem, let's just say that it's a 1 kilogram pendulum to make our lives easier. So we know KE is 1/2 mv squared. We know KE at its lowest point is going to be 10 joules. So this will be 10 joules. So we've got 1/2 mv squared set to 10 joules. If m is 1, that would be 1/2 times 1 times v squared is 10 joules. To get rid of, so we want to get V by itself. To get V by itself, we're going to multiply a half by 1 and get a half. Then we got to get rid of the half on this side. So to get rid of a half, I'm going to multiply by 2. So 2 times a half is 1. I've still got my V squared, and that's going to be equal to 2 times 10, which is 20. So the 2 times the half goes away. I get V squared is equal to 20. To get rid of a squared, I take a square root. So square root of 20. And that's going to work out to, so we would expect it to be somewhere between 4 and 5. So just because 4 squared is 16, and 5 squared is 25. So when we do that, we get 4.47. And that's going to be meters per second. So that's how we would use conservation of energy to solve for the speed of the pendulum.